Core Curriculum Pedagogy, a research and policy-informed discussion focused on cross-curricular issues within science and mathematics. The value of cross-curricular approaches to work in the primary curriculum has long been the subject of debate. It is argued that the cross-curricular approach helps children to understand the world around them by motivating them to learn through stimulating and contextual topics. On the other hand, it is argued that the cross-curricular approach hinders children in acquiring the knowledge and facts learnt when subjects are taught discretely. Throughout history, various recommendations have been made both for and against the cross-curricular approach. The 1870 Forster Act provided a limited curriculum focused on the 3 R's before primary education became compulsory in 1880. The Balfour Act later created local education authorities and removed the control of the curriculum from teachers. By 1931, the Haddo reports encouraged the idea of teaching through activities and experience, leading to the cross-curricular approach. Control of the school curriculum was given to head teachers in 1944, followed by the Plowden Report, which led to organising the curriculum around cross-curricular topics. However, the national curriculum was introduced in 1987 and resulted in a move towards discrete subject teaching. This was further reinforced by the 3 Wise Men in 1992, until Ofsted stated that cross-curricular teaching was a feature of successful primary schools, and so schools began to reintroduce the cross-curricular approach. The Rose Review later advocated a combination of discrete and cross-curricular themes in 2009, and proposed that teachers should be free to use their professionalism and expertise to support all children to progress, allowing more freedom in how they teach. Which leads us to 2014 and the new national curriculum, which emphasises cross-curricular learning and creativity, and will be taught in maintained primary schools from September. So, why use a cross-curricular approach in science? The new national curriculum states that teachers should use different contexts to maximise their pupils' engagement with science. But why is this? Vygotsky's constructivist view of learning contends that children learn through connections formed between prior knowledge and new experiences. Both science education and cross-curricular approaches to teaching are informed by this view. Vygotsky believed that learning is a social process, and further research suggests that learning occurs as a result of communication and interaction within groups. Hayes supports this view, stating that children working collaboratively learn from their own direct experience. The small group work nature of investigative science offers a supportive environment in which to learn, so linking science to other subjects provides children with the opportunity to develop skills socially within real-life contexts. The 2014 national curriculum proposes linking science with ICT, stating that computing has deep links with science. However, the use of ICT in science has been criticised for potentially de-skilling children, which, if children spend valuable time typing when a quick note would have been more effective, then the ICT hinders the science. But there are many ICT tools available that can teach children skills such as to construct and label graphs, while speeding up the process and allowing for children to analyse results and draw conclusions. If ICT is used simply for research and fact-finding, then experimental and engaging science can be lost. However, if the ICT is used to provide real audiences for the children's work, or to carry out investigations or record data using data loggers, which limit the time spent on the lower level skills of recording and presenting data and provide more time for interpreting results and drawing conclusions, then ICT can be of a real benefit and used to optimise pupils' understanding of science. Much of the content taught in primary science crosses over with other subjects, but how is this of benefit? Frykholm and Glassam proposed that integrated curricula provide opportunities for more relevant and stimulating experiences, and types of scientific inquiry can be taught through a variety of subjects to provide context. For example, observation skills can be taught with art, pattern seeking can be experienced through geography, classifying and grouping with history, and collecting and presenting data with maths. In addition, research proposes that both boys and girls in classes using these context-based approaches had significantly more positive attitudes to science than both their high and low ability peers using a traditional discrete approach. This would implicate that a policy embracing the teaching of science through contextualising and relevant context is likely to motivate and have a beneficial effect on pupils' science attainment. However, it is important to note that there is limited research evidence on the effects of this approach for pupils with English as a second language and cultural minorities, and it could be questioned whether it is possible for all children to be motivated by one theme or topic. Whether teaching science skills in another subject or taking the integrated approach, it is important to ensure that both subjects receive equal attention. the cross-curricular approach has been criticised for hindering pupils in developing essential subject-specific skills, and by the Three Wise Men report for not providing a balanced curriculum. So, is there a benefit in using a cross-curricular approach in mathematics? Current policy suggests that it is beneficial to incorporate mathematics throughout the curriculum. The new national curriculum states that teachers should use every relevant subject to develop pupils' mathematical fluency, and that mathematical reasoning should be developed in all subjects so that pupils can understand and appreciate the importance of mathematics. The government's national numeracy strategy introduced the numeracy hour in 1999. While this appeared to increase pupils' attainment levels in maths, research studies found that the strategy in fact undermined the development of a more reflective and strategic approach to maths, and that the stricter time management involved posed problems for the lower attaining pupils. It could therefore be argued that cross-curricular teaching allows more time to be dedicated to mathematics whilst giving the subject context using a more creative approach. Sir Ken Robinson believes that creativity is as important as literacy. The Department for Education and Skills state that promoting creativity is a powerful way of engaging pupils, and Ofsted suggested in 2010 that creative learning is supported by cross-curricular teaching, and so incorporating mathematics throughout the curriculum could help to engage pupils in their learning. The mathematical skill of problem solving helps pupils to develop their mathematical knowledge and can be applied throughout the curriculum. Engaging pupils in a real-life problem encourages them to apply and adapt a variety of strategies to find a solution, and in doing so it is proposed that pupils will often develop new mathematical understandings. Barnes supports this view, stating that the cross-curricular approach helps children to develop problem-solving skills, as it encourages them to synthesise information and ideas from a range of sources. Data handling skills are also given purpose when practiced in other areas of the curriculum. By developing, exploring and justifying real, meaningful data, pupils gain a greater sense of understanding and also enjoyment from mathematics. However, it is argued that when teaching maths with other subjects, subjects can lose their identity, and Alexander suggests that the learning is superficial and fragmentary. Reynolds proposes that if maths does not fit logically into a theme or topic, then the mathematical skills and concepts may not be adequately addressed, which compromises the learning. So, are maths and science natural partners, or does teaching the subjects together cause confusion? It is proposed that science provides opportunities to practice a wide range of mathematical skills within an engaging context, and Freikolm and Glasson suggest that when mathematics and science are segregated, the context of the investigated phenomenon is lost and students are less able to solve real-life problems. The two fields, maths and science, are learned in similar ways and through similar processes, and there is much overlap in the skills taught in each subject. Rutherford and Algren state that science provides mathematics with interesting problems to investigate, and mathematics provides science with powerful tools to use in analysing them. An example of maths and science being used together to enhance learning and understanding is the study of astronomy. It provides an exciting way to introduce children to big numbers and to make data handling contextual whilst learning about the solar system. Common themes in the two subjects include recording observations, comparing data, and using tables and graphs. Data on the planets can be used for data handling, and by using math skills to present the data and graphs, or Venn and Carroll diagrams, the children gain a greater understanding of the solar system. Physical modelling can also be used to enhance mathematical and scientific learning. Accurate scaling and measuring will reinforce the children's math skills while providing a meaningful context. And so, science can provide opportunity to practice a variety of math skills within an engaging context. In addition, the 2014 National Curriculum states that pupils should apply their mathematical knowledge to their understanding of science, and so from September it will be compulsory to link the two subjects together. So, what are the negatives to this? Jarvis argues that pupils' education often suffers due to tenuous links being made between subjects, but is this the case for mathematics and science? The two subjects often use similar vocabulary with different meanings, as well as using different vocabularies for the same meaning, which can cause confusion, especially if subjects are being taught together. However, if this is adequately addressed and equal attention is given to both subjects, then incorporating science into mathematics may hugely motivate pupils. To conclude, mathematics and science are learned in a similar way and can provide context and further understanding to each other. The new national curriculum has given teachers more flexibility to collaborate the two subjects and also highlights the importance of doing so. The current policy does not advocate the cross-curricular approach to the extent of the Plowden report, but this will help prevent superficial learning and guide teachers to make appropriate links between subjects, particularly mathematics, science and ICT. Maths is the language of science, and teachers should allow children to explore this relationship while providing context to the subjects, as without maths, science becomes subjective.